Morning, everyone. Our time is exactly 7:35, as I've promised that we're going to start at 7:35. So I think we can start now. Liwani, may you please mute your mic? Liwani Mapanga, please mute your mic. You can see. Thank you very much. Now we can start. So to give you a background, last time we spoke about simple random sampling with and without replacement. So I introduced that topic on how to select the samples when we are using simple random sampling without and simple random sampling with replacement. So today we are going to select the sample again. I'm going to show you how to select the sample again using a random number table. In other words, how do we draw a simple random sampling using a random number table? This is what we are going to do today. So without any waste of time, let me just go to the window journal so that I can show you how to do that. Can you give me a moment, please, while I'm still... Okay. Bit while I'm still... Can you be able to see my window journal? Anyone?
Yes, sir.
Okay,
Yes, sir.
thank you very much.
Yes.
Yeah, so we can start. Like I said, I'm going to show you how to draw or to select a simple random sampling using the random number table. So this one is lecture number 5. It's lecture number 5. So the heading is how to draw simple random sampling using random number table. Number table. How do we do that? So there are two important points that you have to take into consideration. They are very important in drawing or selecting the simple random sampling using the random number table. So what are they? Number one, so the same subject or the same object or the same number cannot be selected twice. That point number one. Because here you're talking about the random number. So we can say that the same number cannot be selected twice. That's point number one. So the same number or the same object, but in this case we are talking about the number. Same number cannot be selected twice. Okay, that's point number one. Point number two, if a random number occurs twice, the second occurrence, okay, should be omitted or discarded or removed, and another has to be selected as its replacement. You get that? So that's point number two. Let's say if a random number appears to appear twice. Okay. Twice. So the second occurrence or appearance, the second occurrence should be omitted or removed or discarded, and another number is to be selected. Guess what? S is replacement. Get that? So those are the two important points that you must know when you are selecting the sample based on random number table. So point number one, the same number cannot be selected twice. Okay. Number two, if a random number occurs twice, the second occurrence should be omitted or discarded or removed, and another number is to be selected as its replacement. So now let's consider the example on how to do that. So let's just consider the example. Let's say, for example, let's suppose we have to select a 5 random number. Let's say 5 numbers or random numbers from 60. Okay, let's say you have got a population of 60 numbers. Okay, now we just want to select how many? 5 of them. How do we do that? Using random number table. So now let's consider example 3.3 on page 12 on the lecture notes. Example 3.3 on page 12, the lecture notes. I hope you have the lecture notes with you. Okay, so now do you have the lecture notes with you? You are supposed to have the lecture notes with you so that you can refer from what I'm doing. May I ask, do you have a lecture notes with you? Do you?
Yes.
Okay, thank you very much. Now, let's consider example 3.3. You see that? Example 3.3, it says use a table 3.1 of random numbers to select 5 numbers from 60. Okay, table 3.1 is a random number table. So if you check that table, let me just try to write some of the values there in case for those who don't have the lecture notes right now. So that's table, but I'm not going to write all the numbers actually. I'm going to write the numbers that we're very interested in only. Okay, table 3.1. Okay, it's a random number table, this one. So sorry for that. Okay. Value number 1 is 48047, if you see that. Okay. The next one is 45381. Then follows 33232. So that's row number 1. Okay. Then 35178. Okay. Then follows 46971. Okay. Then 85879. Okay. Then 31458. Then the last one on that row is 220160. That's row number 1. Okay. So now we just want to select the 5 random numbers using the random number table. Okay. So this is the table that we're talking about. So now, before I write some of the values, let me show you something here. What we're going to do. So when you select those numbers, it's either you use the 1-digit numbers, okay, or 2-digit number, okay, or 3, depending on the question numbers. Okay. So now in this case, you have been given the population of 60 numbers. Okay. So if you check this 60 here, it's how many digits? It's 2-digit number, isn't it? Okay. So now, let's say we just want to select 5 numbers from 60 using 1-digit number. Okay. So what you have to do, you're supposed to have a starting point. Okay. Starting point is very important in this regard. So, okay, in this case, let's say you just want to start with a 1-digit number. Okay, this one. So the starting point, I have to direct you because if you recall, each and every number there, out of 60 numbers there, each and every number has equal chance of being selected because it's a random number. Okay. Otherwise, if I can't direct you, each and every one just pick 5 numbers. You find that they're okay. There are many simple numbers that you can pick out of those 60. So each and everybody can pick his or her own numbers and find that all of them are correct. So we just want to have an idea and have a uniform thing. So now we are starting with the first digit number. So first digit number, where do we start? So in this case, we're going to start. Let's say we consider row number 5. Row number 5, okay, from that table 3.1, and what, and column, let's say column 60, and column 60. This is where we're going to start to draw what, the 5 numbers using what, 1-digit number. Okay, so now, like I said this one is our first row. Okay, so but here our starting point is from row 5. So if you check from the table there, row number 5 starting at what? 1, 2, 3, 4, 5. Row number 5 Start at, let me just write it down. This one is row 1. Okay, so we just want row number 5. Okay, start at what?
It's 5, 8.
Start at 5, 8. Yes, thank you very much. Start at 5, 8. Just write it down. 5, 8.
5, 4,
5,
7.
4, 7. Okay, thank you. Then follow us 0, 1, isn't it?
3, 3, 1.
3, 3, 1. Okay. Then next
6, 2, 5, 3, 8.
Oh, 5, 3, 8. Okay, sir.
Yeah, 5, 3, 8.
Then follow what?
7, 9. Yeah, 1, 8, 1.
1, 8, 1. 1, 8, 1. Okay. Then follow what? 3, 3.
3, 3, 0,
0, 7,
7,
1.
1.
Okay. Then the next one.
6,
6,
3,
3.
7, 6, 6.
7, 6, 6. Then the next one.
7, 3,
7, 3.
6, 1, 3.
6, 1, 3. The last one in that row.
2, 4,
2, 4, 4.
7, 0.
7, 0. Okay, now this is row number 5. Remember, we're starting at row number 5, column 16. So let me show you how do you find columns. It's not according to what they represented there. So in this regard, the columns are represented in this way. Let me show you. In row number 1, okay, the first value there is 4. 4 is in column 1. Okay. 4 is in column 1. 8
Sorry,
is
sir.
column 2. Yes, yes, yes.
Can I ask why are we starting
Yes.
from row 5, column 16?
Yes, it's what I've just chosen myself. You can start anyway, but as I've already indicated, I said we just want to have a uniform thing. So I can start anyway, but in this case, we're starting from row 5, column 16. There's no reason for that. You can start anyway because those are the random numbers, isn't it? But for now, I have to direct you so that you can have the same
Okay.
thing. Okay. So now, column 1 is 4, column 2 is 8 from row number 1. Can you see that? This is 2. Column 3 is 0. Column 4 is 5. Column 4 is 4, sorry. Column 5. Column 6 is 7. Do you follow that? So in other words, it's like this. These are our columns. Okay. These are our columns. 4, 5, 3, 8, 1. Oh, sorry. Yes, 0 and 1. Sorry. Put this one. Yes, I will write it again. Just want to show you how do we read the columns. 0, 1, column 5, 0, 1, 3, 3. 1, okay. Then row 1 is 3, 4, 5, 3, 8, 1. Okay, so the columns 4 for row 1 is column 1, and 8 in row number 5 is in column 1. Okay, And 8 in row 1 is column 2. 0 is column 3. 4 column 5 for row number 1. 7 column 6. Then 4 is column number 8. This one is column number 7, and so on. Do you get that? Now, we're starting from row 5, column 16. Row 5 is this one. Okay. So column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is here. This is our starting point. Do you see that one? 16 is here. Do you follow? That's row 5, column 16. The starting point, because we are using one digit number, the first digit number that we are going to consider is 7. Because it's in row 1, column 16. That is our starting point. Are we together? So that means here for one digit number, we're using the one digit number. Sorry. The first value is 7. Okay? The second one is what? So now we're starting from row 5, column 16, going to the right. So that you can have an idea. Going to the right. So in other words, we're starting from 7 going this way. Okay? Start from row 5, column 16, going to the right. Okay? So, and we're using the one digit numbers. So the first value there is 7 because it's our starting point. What is the next value there? We remember we're selecting 5 numbers from 60 in table 3.1. So the first number now is 7. The next one is what?
9.
It's 9. Thank you very much. The next one?
1.
It's 1. Okay. The next one?
8.
It's 8. Thank you. Following one?
1 again.
It's supposed to be 1, but because 1 is repeating, you see that? We have to
Yes.
omit it and go to the next one. So what is the next one?
3.
It's 3. Do you get that? So we have how many now? 1, 2, 3, 4, 5. This is our first random numbers using random number table for the first digit numbers. So it's 79183. We were supposed to repeat that other one, but because of that 2 points that I was highlighting at the first point there, we can't include that one. We have to remove it because it's repeating. So that is why at the end of the day, we're having 79183. Do you get that? Okay. Now, let me give you another example so that you can understand it better, but still using one digit number so that you can understand it. Okay, let's say you're still using one digit number. Numbers, because there are many. Let's say we have a starting point at row number, let's say row 3. But in this case, if
Sorry, sir, can I ask something?
yes.
What do we mean by one-digit numbers, two-digit numbers, and three-digit numbers? What does that mean?
Oh, in other words, you want to understand what is a digit. Digit is, when we say one digit number, we're referring to only one value, one number, okay? Two-digit number is 2 values. Let's say 1 and 1. Those are the 2-digit number. Or 72. I'm just giving you a scenario. These are 2-digit number. But 1, 2, 3, 4, and so on. Those are the what? The 1-digit number. So these ones are the 2-digit number. So 3-digit numbers is 111 or 203. So these are the 3-digit numbers. This is what we're referring to.
Okay, thank you.
Okay. So now, let me just erase this. Now again, we're considering 1-digit numbers. Okay, let's start from, in this case, let's say, because I don't want to write another thing. Let's start from row 5 again, but with a different column. Okay, so let's start from row 5, but column, let's say from column number 1. That's our starting point. Okay. Okay. We're going to start at row 5, column number 1.
Sir,
So, yes.
what about the case whereby we're having, let's say, 2 or 3 digits numbers? Are we going to have if we're having 2 or 3 digits numbers, then we are instructed to get five values. Are we going to have a group of 5 value, a group of 3 digits of 5 values, or we are going to have or we're going to have 5 values?
So yeah, I understand what you're saying. So in other words, if it's 3-digit number, but in this case, you are controlled by the numbers, population numbers that are there. Here is a 2-digit number. You see that one? So in this case, so it's going to be difficult for you to find them, all 5 of them, because for 5-digit number, actually in this case, so that let me just give you another scenario. In this case, we are looking from values, it's very important, from 1 up to 60. Okay, those are the values that we are going to consider to find 1-digit number or 2-digit number or 3-digit number. So in this case, those are the values that we are going to consider. The values that are between 1 and 60. 1 is included and 60 included. But the values that are not there, they are not included. So, but anyway, you'll see this one when we come to 2-digit numbers. So in this case, we are just directed by this. Okay. So for 3-digit number, obvious, you are going to start from 1 up to something for 3-digit number. So let's say for 600. Okay, because this one is a 3-digit number. So you're going to be guided by that. But however, if you just want to find the values from between 1 and 60 using 3-digit number, so the numbers that we are going to have there, possibly you can find 0, 0, 2. You see this one, 002. It's the same as 2. But at the end of the day, it's a 3-digit number because it's 002 if it's there. So it's under 3-digit numbers. Okay. So, but anyway, I'll try to explain this one when we come to it. But to answer your question, so if you are looking for 3-digit numbers for 5 random, and you want to find what 5 samples, 5 samples. So you're going to have, let's say, 2, 1, 1, depending to whether it's in between that interval, and another one, let's say, is 4, 5, 6, and let's say it's 2, 0, 0, say it's 1, 1, 1, let's say it's 109. Okay, so you see them. These are 3-digit numbers. Okay, 3-digit numbers, 3-digit numbers. But how many of them? Values 1, 2, 3, 4, 5. Because we want what? N equal to 5. 5 samples. Because we were selecting how many? 5 numbers, sorry, not 5 samples, 5 numbers. This is the sample that you are going to have. But using 3-digit numbers. So that's why we're having 3-digit number here, 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 and here. But we want to find what? The sample of 5. I don't know whether I have answered you. But you'll find this one when we go on. Because now we are still in digit number 1. The one we've asked, did I answer it?
Yes, Amatar.
Okay. So now, we are still in the 1-digit number. So let me just erase this one because I was just explaining. So let's go back to the 1-digit number. But in this case, we are starting from where? Row 5, column 1. Again, going to the right. Okay. Going to the right. So let's, sorry. Row 5, column 1. Row 5 again is this one. Sorry. Row 5, sorry, is this one. This row number 5. But we're starting from column 1. Column 1 is this one. This value here is column 1. But in row 5. So we are starting from that. And that number is what? It's 8. It says it's 88547. Okay. So now let's select them now.
It's 5, sir.
Come again.
It's 5.
The first value is what? The first value is what?
5.
It's 5. It's 5. Not 8.
Which one is row 1?
Yeah,
sorry,
you
row
wrote
5.
5
Column 1 is what?
5.
Is it
It's 5.
this one?
Not 8.
It's 8. This one, sorry. Oh, it's 5. Yes, it's 5. Sorry. 1, 2, 3, 4, 5. It's 5, 8. The way I wrote it. Yeah, this one is 5. So it's 5, 8, 5, 4, 7. Yes, the first one is 5. Okay. Second one
It's 8.
is 8. Then follows
4.
4 because it was supposed to be 5, but because it's repeating, we leave it. Then 4. Next one
7.
7.
7. There are many
0.
1, 2, 3, 4. The next one is 0. So those are the 5 numbers that we're considering using 1-digit numbers. I think for 1-digit number it's clear. Okay. So now let's go to 2-digit numbers now. 2-digit number. Okay. 2-digit numbers. Again, let's start from row 5, column 16. Now it's 2-digit number. Row 5, column 16.
Sorry, sir.
Yes.
So are we done selecting the numbers from question number 1? The 5
It says,
random 1-digit numbers.
hey, we are done. If you are using, those are the random numbers that we're talking about.
So we just select going right and then that's it.
Yeah, that's it. So, but now we're in 2-digit numbers now. Okay, let's go to 2-digit number. Now, the starting point is what? Row 5, column 16. Row 5 is this one again. So column 16 is here. This is the starting point at 7. But remember, because we are dealing with the 2-digit numbers, so that means it's going to be this one. It's going to be this one. This is the starting point for 2-digit numbers now. So the first value is what?
79.
79.
79. But remember, we are looking for the values between 1 and 60. Okay? But 79 is not in that interval. It's outside. Remember, from 1 up to 60, this one. 79 is outside the interval, so you can't take it. So the values that are here and the values that are here, in other words, the values that are less than 1, we won't take them. The values that are, so actually even that one, I think we made a mistake here. We made a mistake here. We were not supposed to include 0 there because it's not in between the 1 and 60. Do you see that for this one? We're not supposed to include it. We are including the values, all the values between 1 and 60. All that are not between 1 and 60, they are not supposed to be included. So, in other words, all the values that are less than 1 and all the values that are greater than 60, okay, are not supposed to be included. So here, I think we're supposed to remove that 0 and replace it with what? With 1, isn't it? Yeah. You get that?
Yes,
0,
it makes
0 is not supposed to be. So this is 1 here instead of 0, because we are looking for those values that are between 1 and 60. Sorry. Okay, I think it's clear. Now, for 2-digit number, you said it's 79, and 79 is outside the interval there, so it can't be taken. So the next one is what? You can tell me. Next value, 2-digit number.
I think it's
18.
18, sir.
It's 180. Thank you very much. 180. The next one?
130.
13.
13. Next one?
30.
30. Next one?
16. 63.
So 71, it can't, 63, it can't, 76, it can't, 67, it can't. So the next one is what? 36. You see that one?
The second one is 24.
Yeah,
36.
13, it can't because it's repeating, then 24. I think we're together. So those are the values that we're looking for 2-digit numbers.
So, sir,
Mm.
let me say they want 5 values.
Mm.
And for that range, we reach the end without having the total number.
Yeah. Okay, I get it. You reach this point, this one.
Without getting, while we are still at 3.
You go to the next one, to the next row that follows here.
If it was the last row.
Yeah, if the last row, so that it's very important. If it's the last row, they will make sure that all the values are there. If it's the last row, you can't do anything. Unless in that scenario, because let's say whatever you're saying that you are starting from 5, going to the right, then we end to the last row without getting all 5 numbers. So I think you can just go back to row number 1 in that regard.
Thank you.
Yes. You have to go to row number 1 because you have not yet selected them there. Any question?
Okay, so on the test, are you going to specify which row and column to select?
Yes, clearly so. I have to direct you. Because if I don't do that, each and everybody just find his or her own numbers. And which are correct, remember? Because those are the random numbers. You can choose any numbers. All of them are correct. But I have to direct you so that you can have a uniform answer. Any question? So the rest you would, yes.
So can you please check the last number? I think it's 13.
For 2 digits.
Yes.
Okay, the last number, which is 24. This one.
Yes.
Sir,
Okay.
We skipped
You are suggesting
13.
what?
we skipped
skipped 13.
13. We skipped 13 because it's repeating.
Yes, repeating 13.
Oh, okay. Thank you.
Okay. So I think that is the procedure for all the digit numbers. The rest you'll find them, I think, in the tutorial. I think they are there, so you can do that. So can you go to another topic? Let me just scroll down. Okay, let's go to the estimate. Yes. Any question? None. So estimation of population mean and total. There's some noise there. I don't know whether there's somebody who's asking question or what. Make sure that your mic is muted if you are not talking. Okay, let's go to this, the estimation. So we're still in simple random sampling. Okay, it's about simple random sampling. Okay, but in this case, we just want to estimate the population mean and the population totals. So the estimation of the population mean and total. So how do you estimate the population mean and how do you estimate the population totals under simple random sampling? Okay, there are many formulas that you have to consider in this case. Number one, so to calculate the population mean, we use, let's say the population mean is given by mu.
Yes, we don't see what you are writing.
I said the population is the population mean I wrote there. The population mean is given by mu, which is equal to sum of y over n. Okay, that's the population mean. If you want to calculate the population mean, this is the formula that you have to use under simple random sampling, which is equivalent to y1 plus y2 plus yn. Okay, all divided by what? By n. So in this regard, y1 up to yn, this one, we call them, those are the values of a random variable, of random y, let's say of variable y. Okay, the one on the numerator are values of random variable y. Okay, and this one, big N, represent the what? The population size.
So we can't
We are
see
familiar.
anything.
Come again. Is there anyone who's asking question?
We can't see what you're writing, sir.
You can see them.
Yes.
Hey,
No,
what is
we can see
happening?
some
We see.
Eh?
Oh, now it's fine. I think you were not scrolling down before. You were just writing.
We can see.
But you can see that.
Yes.
You can see everything you're writing.
Okay. I was saying that in this case, we are estimating the population mean and population total. So to calculate the population mean under simple random sampling, we use this formula mu equal to summation of y over n, which is equal to y1 plus y2 plus up to yn, where y1 plus y2 up to yn is represented as the values of the variable y, and the capital letter N represented the what? The population size. Okay. So how do you calculate the population total now? So for population total, we use abbreviation tau. Okay. Tau, which is equal to N times mu. Okay. And N is capital letter N is population size, mu represent the population mean. Okay. Think it's clear? So if you want to calculate the population variance, we use the symbol sigma squared, okay, which is equal to the sum of y minus mu all squared divided by n. Remember, in the lecture notes, I think I divided by n minus 1. Please just go and rectify that one. Is sigma squared equal to the summation of y minus mu all squared divided by n, big N. Why big N? We realize that the one that we divide by big N is more sufficient than the one that we divide by n minus 1. What does that mean? It means that the variance that you get when you divide by n is smaller than the variance when you get after dividing by n minus 1. So remember, here we just want to minimize the errors as possible. Okay, so that means the smaller the variance, the better. So that is why in this case we are using sigma squared, which is equal to the summation of y minus mu all squared divided by n, not n minus 1. So I remember that in the study guide there, I divided by n minus 1. Please, it's on page 14. Page 14 there, I said sigma squared is equal to summation of yi minus mu all squared divided by n minus 1. Just divide it by n instead of n minus 1. I think it's clear. Okay, now I'll show you how to calculate the population mean, population total, and population variance. So now the estimation of the population mean is given by the estimation of the population mean. You know that when you estimate the population mean, use mu hat, isn't it? You use mu hat. It's the estimation of the population mean. Sorry. Which is equal to what? Y bar, isn't it? It's the estimation of the population mean, which is equal to what? To the summation of y over n. Okay. So, and this can also be written as what? Y1 plus Y2 plus Yn. All divided by what? By n. So here again the values of variable y, okay, and this one is a sample size. Okay, so this is when we want to estimate the population mean. You use mu hat, which is equal to y bar, which is equal to the summation of y over n. Okay. Now, when you want to estimate the population total, estimating the population total, we use again tau. Because we are estimating it, we put a cap. Estimating the population total is equal to n times what? Mu hat, which is the same as what? N times y bar. Okay. So again, if you want to estimate the population variance, estimating the population variance, you're going to have, sorry for that. If you want to estimate the population variance, you're going to have sigma squared with a hat, because you're estimating it, which is the same as s squared, which is given by this formula, yi minus y bar, or y over y bar, depending, divided by n minus 1. So this is the estimation of the population variance. Okay. I think we are together. Then, so if you want to find the variance of the estimated mean, just write it down so that you can see variance of the estimated population mean.
So
Yes.
the formula of the sample variance, isn't it the sum of yi minus y bar all squared?
Come again?
That formula doesn't have to the power 2. Only sum
Thank you very much.
yi
Yeah,
minus
you're
y bar.
right. Even here, let's say y, because we didn't specify. It's y minus y bar. Yeah, thank you so much.
Sir,
Yes.
why this time you divide by n minus 1?
This one. This one is always be like that. I was referring to that other one. This one is always be like that, n minus 1. There's no way we have to y minus y bar squared divided by n.
Which one
It's
was,
only on that population.
on which one?
Come again?
On which one are we using n instead of minus 1?
Oh, I said for the population. For the population, yeah. I think I should. Yeah. Here we said we don't use n minus 1. And then I gave the reason for that. Okay. Sigma squared is equal to summation of y minus mu all squared divided by capital letter N. It's only for the population. But for the sample, you have to divide by small letter n minus 1. Yeah. Yeah. This is for the sample. It's n minus 1. Even here, it's not wrong, but in our case, we realize that here, when we divide by n minus 1, the variance is too big as when we divide by n. So that is why at the end of the day, we ended up saying that, okay, let's just divide by n. It doesn't have any harm. It doesn't have any harm anyway. But for the sample, it's divided by n minus 1. I don't think there is anything confusion. So now, the variance of the estimated population mean written as what? As var of y bar. So the variance of the estimated population mean is written as var of y bar. You have to know that. Okay? And the var of y bar is equal to n minus n divided by n minus 1 sigma squared over n. That is the variance of the estimated population mean. Is the var of y bar, which is equal to n minus n divided by n minus 1 sigma squared over n. Okay. So the variance of the estimated population total, the variance of the estimated total is given by the var of tau estimate, which is equal to n minus n divided by n s squared over n. Sigma, sorry. Let me see. Sorry for that. Wait. There's something which is not right here. Even here. Something which is not right. So we have n squared here. Okay. And here we've got n minus 1. Then here we've got sigma squared over n. Yeah, it's like that. So this one is the variance of the estimated population total, which is equal to the var of tau hat, which is equal to n squared open brackets n minus 1 n minus n minus n minus 1 multiplied by sigma squared over n. So you have to check the difference between these two, this one and this one. You see where is the difference? Okay, you have to note that because they might confuse you at this sometimes. So this is the variance of the estimated population total. Okay. Now, the estimated variance of the estimated population mean, let me just write it down. To calculate the estimated or estimating the variance of the estimated, this is like estimating the variance of the estimated population mean. It's written as sorry. Yeah, it's written as var estimate, okay, open brackets y bar. So this symbol is represent what? The estimated variance of the estimated population mean, or estimating the variance of the estimated population mean is the var estimate y bar, which is equal to what? N minus n divided by n close brackets s squared over n. So this one is the estimated variance of the estimated population mean. So when you want to calculate, or if you want to estimate the variance of the estimated population mean, this is the formula. Okay. So now, estimating the variance of the estimated population total, so it's going to be like this. Var estimate, tau estimate, which is equal to n squared, open brackets, n minus n, n. Okay, s squared over n. This is the estimated variance of the estimated population total, or estimating the variance of the estimated population total. This is how we write it. Okay, so this can also be written as what? Sn open brackets n minus n, s squared over n. It's the same thing because here is n cancel n. Yeah, this one cancel this one. So that's what at the end of the day we are having this one. Okay, that's it. Now, so now let's find the standard error of a simple mean. Standard error simple mean, which is what? SE y bar, I think. Standard error of a simple mean, it's equal to what? The square root of the estimated variance of the estimated population mean, var of y bar. See that one? So if you want to calculate the standard error of a simple mean, that is the formula, which is equivalent to what? The square root of what? Of n over n s squared over n. So this is the one. Okay. Okay. Now, the bound on the error of the estimation for the estimated population mean. The bound, I think you spoke about the bound before. The bound on the error of the estimated population, the bound on the error of estimating the simple mean. In other words, simple mean we are referring to this one. Or the bound on the error of estimation for the sample population mean. Okay, it's given by B, which is equal to 2 times the square root of estimated var of y bar. It's the bound on the error of estimation. Oh, bound on the error of estimation. Sorry, here. Bound on the error of estimation for the simple mean. It's bound on the error of estimation for the simple mean, or bound on the error of estimation for the sample population means, the simple thing, which is given by B equal to 2 times the square root of the estimated var of y bar. Okay. And this can also be written as what? 2 times the square root of what? Of n minus n divided by n s squared over n. It's the same thing. That's the bound. It's the bound just because that is why it's having 2 here. That's it's the bound on the error. So which is it's like the standard error of a simple mean, as you see, but the only difference is that this one is having a 2 and this one doesn't have a 2. So that's why it's defining the bound, the interval on the error of the estimation. So that's why it's having 2 here to indicate that indeed it's a bound. Okay. So now the bound on the error of estimation for the estimated population total. Let me just go up a bit. Sorry. Now the bound on the error of estimation for the estimated population.
Some of us, we can't see what you are writing on the screen.
You can't see? Can you see now?
I think it's their networks.
Yeah, it's the network. But now can you be able to see?
Yes, we can see, sir.
Okay, thank you very much. So the bound on the error of estimation for the estimated population total. This one was the bound on the error of estimation for the estimated population mean, or simple means the same thing. So this now is the bound on the error of estimation for the estimated population total, which is abbreviated as what? So this one is for y bar. Okay. No, tau estimate. So this one here, you're estimating tau. Okay. So, but the bound is given by 2 times the square root of the estimated var of the tau estimate. Okay, which is equal to 2 times the square root of what? N open brackets n minus n s squared over n. So that is the bound on the error of estimation for the estimated population total. Okay. Now, let's go to the bound on the error of estimation for the population mean. Remember, the first one here, it was the estimation of the estimated population mean. Now we're going to the bound on the error of estimation for the population mean. And see how the formula looks alike. Okay, now this one, like I said, is a bound on the error of estimation for the population mean. And the population mean is what? It's mu, isn't it? So it's given by what? By b equal to 2 times the square root of what? The var of y bar, which is equal to what? 2 times what? The square root of var of y bar is n Hey, not y bar. Yeah, it's y bar. It's n minus n over what? N minus 1. Okay. Multiplied by what? Sigma squared over n. Yeah. So this one is a bound on the error of estimation for the population mean, which is mu. It's given by b, which is equal to 2 times the square root of var of y bar, which is equal to 2 times the square root of n minus n divided by n minus 1 multiplied by sigma squared over n. Can we have a break?
No, sir. We'll knock off at 9.
Okay. We continue until 9. Then we
Yes, sir.
stop. Okay, thanks. So this one is a bound on the error of estimation for the population mean. Now, let's go to the bound on the error of estimation for the population total. So, the bound on the error.
Sorry, sir.
Yes.
On the bound in the error of estimation for the population mean, what is that in the brackets there?
It's a mu.
Oh, okay, thank you.
Yes, a mu. Bound on the error of estimation so I'm writing this so that you can have you can follow what is the meaning of those symbols and all those stuff. Otherwise, I was not supposed to write bound on the error, bound on the error. I was supposed to just write the formula, but I wanted you to follow this so that you can understand and very quickly adjust. Bound on the error of estimation for the population total. Total. In other words, within the brackets, the tau. Okay. Now it's written as b equal to 2 times the square root of the var of what? Tau. Estimate. Which is equal to 2 times the square root of what? Of n squared. Open brackets n minus n. N minus 1.
Good morning.
Sigma squared over n. So this one. It's a bound on the error of estimation for the population total, which is b equal to 2 times the square root of var of the estimated tau, which is equal to 2 times the square root of n squared. Open brackets n minus n divided by n minus 1 times sigma squared over n. Yes, those are the formulas that I wanted you to know. Let's quickly go to the example then. So you have to know these formulas, even though they are going to be provided when you write the test or the exam, but it won't be provided when you write a quiz, isn't it? So you have to know them. They are very important. Okay, now let's consider this example. We just want to apply what we've been talking about here. The example, I don't think it's there on the lecture notes. It's not there. It's just an example that I want to give you. Sorry. Sample. Okay, suppose we have the sample of n equal to 2, let me write sample. Suppose the sample of size n equal to 2, actually there are samples size 2 were selected from the population. The population of selected from the population of 1, 2, 3, and 4. Okay, sample of 2 has been selected from this population using simple random sampling without replacement. Okay, that's the question. Given information. So the question says, number A, list all the possible sample samples of size n equal to 2. Think it's simple. You can do that. B, calculate the sample mean. Sample mean, we are referring to the estimated population mean, isn't it? It's the sample mean. Calculate the sample mean for each sample. Okay. Sample that you have listed there at B, part B. So you have to find the mean for each, or simple mean for each. Then calculate the sample variance. Calculate the sample variance. Here sample mean, we are referring to y bar, isn't it? Here sample variance, we are referring to s squared. For each sample. Okay. Number D. Calculate the estimated variance of the sample mean. The estimated variance of y bar for each sample. Okay. The last one, calculate the estimated variance of the estimated population total for each sample. Those are the 5 things that I want you to do, but you can do it together. But I just Just want to give you a hint, then we will take it from there. Okay, now let me just, so these things you are going to do it in the form of a table so that you have a good thing.
Sir,
Oh, yes.
can you repeat on the E, like
Number E.
yes, sir. What is
It
it?
says calculate
Yeah.
the estimated
Yes, sir.
variance of the estimated population total, which is a tau head for
Okay, sir.
each sample.
Thank you, sir.
Okay. Sorry. So what I want you to do, solution. So I want you to have a table to make it easier for you. Have a table where you're going to have sample. Okay, let me just say sample. And the elements in a sample. In a sample, then the sample mean, then the sample variance, then the estimated variance of the sample mean, which is the var estimate of y bar. Then for each, isn't it? The estimated variance of the estimated population total, which is the var of tau hat. Then later, maybe you can find number F, the probability of a sample, or the probability of each sample. Yes. In other words, PS. Calculate the probability of each sample. So this is the P of S. Okay. So that means here you're going to have P of S. So how many columns? 1, 2, 3, 4, 5, 6, 7. So you're going to have something like this. So you know how to find the number of ways of selecting the sample, isn't it? Because here you have been given what? It's a simple random sample without replacement. You know how to find the number of ways. After finding the number of ways, you will tell me how many samples are we going to have there. So in other words, what I'm saying is here you are going to have sample 1, 2, up to, depending to the number of ways. So here elements in a sample. So that means you are going to have what? Let me just give you an example. 1, 2. Okay, then you find the mean here, then you find the sample here, you find the variance, estimated variance, sorry, for sample mean, find the estimated variance for estimated population total, then you find the probability of that sample. We are left with 1 minute, so can I just say, just go and do it? Then we can
Yes,
give it a
we'll try to do it, then we'll come with the results. Do you
yeah,
have
on
the
tomorrow.
tutorials it's tomorrow?
It's today. Today is Thursday, isn't it?
It's this day.
Yeah, at 1 o'clock we have a tutorial.
Oh, please, you must record it since we don't know whether the load shedding may affect us or not.
Let me check. I don't think we have a load shedding. Let me check for you. Don't think we can have a load shedding.
Load shedding is suspended for today.
Oh, suspended for today. Yeah, we don't have it. At 1. So it's from 1, isn't it? From 1 until 20 to 2. It's a tutorial. Please just go and work on those tutorials. Then when you come, just ask for clarity.
Sir,
Yes.
myself, I'm
Yes.
just asking you to just record it, even though there will be electricity. Just record
Oh,
it
okay.
for us.
Yeah, I'll do that. I'll do that. Okay, I think you can stop here. And then just go and try it.